Hello everyone, here discuss Freundlich adsorption isotherm, part of surface chemistry. In 1909, Freundlich proposed an empirical equation as x by m is equal to k into p raised to 1 by n, where x is amount of adsorbate, m is amount of adsorbent, P is pressure, and K and N are the constants for given adsorbate and adsorbent at constant temperature. By taking logs of this equation, log of x by m is equal to log of k plus 1 by n into log of p. The plot of log of x by m against log of p should be straight line with intercept on y-axis is considered log of k and slope is equal to 1 by n. The graph shows that as P increases, that is as pressure of that adsorbate increases, then x by m also increases. Actually, experimentally, straight line graph is obtained only at low pressure range. This one is limitation of that Freundlich adsorption isotherm. Other limitations for Freundlich adsorption isotherm are, first one is, this one is valid only for certain pressure range. Second one is the constants, that is temperature, that constant terms, that is the in equation that k and n are the constants and that terms are temperature dependent. Constant terms are temperature dependent, and this Freundlich adsorption isotherm have no any theoretical background. This one is about that Freundlich adsorption isotherm. Then next adsorption isotherm, that one is theory for that adsorption process, is a Langmuir adsorption isotherm. This adsorption isotherm is based on following assumptions. Langmuir adsorption isotherm based on following assumptions, considerations. First consideration is that adsorption on solid adsorbent is considered as a monolayer, that is unimolecular adsorption. Second, there is no interaction between adsorbed molecules on the surface of adsorbent. Third, amount of gas adsorbed depends upon surface area of adsorbent. Then third one is rate of adsorption is directly proportional to the surface area of adsorbent. Rate of adsorption is directly proportional to the surface area of adsorbent. Therefore, rate is higher in beginning and decreases as decrease in availability of uncovered surface of adsorbent. Then next, fifth one is adsorption is dynamic process. That is, it consists of condensation, that is adsorption, and evaporation, that is deadsorption. Evaporation means deadsorption. And at equilibrium, these two processes become equal, that is condensation and evaporation processes, rate of these two processes becomes equal at equilibrium. Then rate of adsorption is directly proportional to the pressure of that adsorbate gas, and the gas under study is considered as an ideal gas. On these, on the basis of these assumptions, on the basis of these postulates, Langmuir expressed an equation showing quantitative relationship between pressure and amount of gas adsorbed at constant temperature. Let Q be the total covered area of adsorbed molecules, covered area by that adsorbed molecules, and 1 minus Q is surface, uncovered surface, which one is not covered by that molecules. Then, according to the kinetic theory above postulates, adsorption rate is directly proportional to the pressure and available surface area of that adsorbent. Therefore, we can write that rate of adsorption is directly proportional to 1 minus Q. 1 minus Q is nothing but uncovered surface area into P. P is pressure of that adsorbate gas. Then by removing proportionality, consider K is constant, then rate of adsorption is equal to K into 1 minus Q into P. Then K is proportionality constant here. Similarly, rate of deadsorption, that is evaporation, is proportional to Q. What is Q? That is surface which one is covered by that adsorbed gas molecules. Therefore, rate of deadsorption is proportional to Q. Q is, what is Q? Surface area which one is covered. Already adsorbed molecules are there. Therefore, considering constant, that rate of deadsorption is equal to K dash into Q. Then at equilibrium, this adsorption and deadsorption that are equal. Therefore, K in bracket 1 minus Q into P is equal to K dash into Q. By rearranging and solving this above equation, we got Q is equal to Kp upon Kp plus K dash. Kp upon Kp plus K dash. And the amount of gas deadsorbed by 1 gram solid adsorbent is proportional to its area occupied. Therefore, A is proportional to Q. That amount of gas deadsorbed is considered as A and proportional to Q, that is area occupied. Therefore, next constant consider K double dash, that is removing that proportionality, that equal to K double dash into Q. Therefore, what is Q? Q is nothing but Kp upon Kp plus K dash. Substitute that. Therefore, this equation become K double dash in bracket Kp upon Kp plus K dash. Then dividing the numerator as well as denominator by K dash. Then we got A is equal to K1P upon K2P in plus 1. This is considered equation 1, where K1 is equal to K double dash into K upon K double dash into K upon K dash, and K2 is K upon K dash. This is nothing but Langmuir adsorption isotherm equation. A is equal to K1P upon K2P plus 1. This Langmuir adsorption isotherm, and to verify above equation, divide both sides by P and then taking reciprocals. Divide first by P and then taking reciprocals. By dividing P, this equation become A by P is equal to 1 upon P into K1P upon K2P plus 1. Then taking reciprocals, this equation become P upon A is equal to P in bracket K2P plus 1 bracket complete upon K1P. Therefore, rearranging P upon A is equal to K2 upon K1 into P plus 1 upon K1. Then if we plot a graph of P upon A versus P, that should be straight line with slope is equal to K2 upon K1 and intercept on that x-axis is equal to 1 upon K1. Intercept on y-axis. That intercept on y-axis is equal to 1 upon K1. Then K1 and K2 that are here calculated experimentally. Langmuir equation indicate that consider case 1. At low pressure, when pressure is very low, K2 into P is very small. Therefore, that K2 into P become very small, less than 1 and therefore neglected. And if that one is neglected, that equation Langmuir adsorption isotherm equation become A is equal to K1 into P. Therefore, A is proportional to P. A is directly proportional to P. That is, that amount of adsorbed is directly proportional. That depends on pressure of that adsorbate. Then case second, consider pressure is very high. Then if value of P is high, K2 into P is greater than 1 and therefore A is equal to K1P upon K2 into P and therefore A is equal to K1 upon K2. That means that become constant, and limitation of that Langmuir adsorption isotherm is that it consider monolayer adsorption only. This one is based on monolayer adsorption process. Then in next lecture we discuss afterward that beat equation, which one is also known as beat isotherm. Thank you. We stop here now.